This AI is trained on stock market data. Kronos is an open-source model for financial chart data. Instead of starting with a pile of handwritten indicators, it learns from the candle charts traders already use. Open, high, low, close, and volume over time. The repo turns those candles into tokens a model can understand, then uses that representation to forecast what may come next. It is research tooling, not a trading app. The basic move is easy to understand. A market candle is not just one number. It carries open, high, low, close, volume, and amount, all moving through time. Kronos takes that noisy stream and builds a tokenizer around it. Once candles are converted into discrete tokens, a decoder-only transformer can model the next part of the sequence. That makes Kronos feel closer to a language model for markets than a normal numeric forecaster. The training data matters because financial time series have their own shape. The README says Kronos was trained on data from more than 45 exchanges, giving the model a broader view than one ticker or one market regime. That does not make the future predictable. It means the model is learning recurring candle behavior, pressure, reversal, drift, and volume shocks. The best audience is not someone looking for a buy button. It is people who already work with market data and want a stronger modeling primitive. Quant researchers can compare learned signals against classical factors. ML engineers can study a clean domain-specific tokenizer. Tool builders can wrap the predictor into research workflows without starting from a blank notebook. The public repo is unusually small for the amount of attention around it. GitHub shows 22.6 thousand stars, 4.0 thousand forks, 76 commits, and an MIT license. That shape is worth noticing. The idea is research-heavy, but the implementation is compact enough to inspect. You can read the examples, trace the predictor, and understand where the modeling boundary sits instead of digging through a huge platform. The repo layout stays focused. The model code sits in its own package. The examples cover single prediction, batch prediction, no-volume prediction, and backtesting. Fine-tuning has its own path, and the web UI gives you a chart-driven way to test forecasts without writing a full interface yourself. The README also spends real space on the model zoo and the research paper, so the repo reads like a bridge between a paper release and a usable research tool. The architecture is where Kronos separates itself from generic time series tooling. It does not simply feed raw numeric arrays into a transformer and hope the model figures out market structure. The tokenizer first quantizes continuous K-line data into hierarchical tokens, then the predictor learns over those tokens. The model learns a vocabulary for financial candles before it forecasts what comes next. That tokenizer-first approach is the real bet. Classic indicators compress the market by hand. A general time series model often treats each feature as another column. Kronos tries something more specific. Turn the candle into a symbolic sequence that the model can reuse across assets and windows. If that representation is good, then the forecast model is not just memorizing numbers. It is learning reusable patterns in how candles evolve. The model sizes make experimentation realistic. Kronos Mini is 4.1 million parameters. Kronos Small is 24.7 million. Kronos Base is 102.3 million. Kronos Large is listed at 499.2 million parameters, but it is not open-sourced in the table. That means most builders are probably starting with Mini, Small, or Base, then deciding whether the approach is worth deeper tuning. Forecasting is wrapped in a predictor class, which keeps the first run approachable. You load the tokenizer and model from Hugging Face, pass in a pandas data frame with recent candles, provide the future timestamps you want, and get back a forecast data frame. The API handles preprocessing, normalization, prediction, and inverse normalization. The important part is that the example looks like normal Python data work, not a custom research runtime. Batch prediction is a practical feature because market research rarely stops at one chart. You often want to test the same assumption across a basket of instruments, compare several assets, or run a small portfolio experiment. Kronos supports batch forecasting when the context and prediction windows line up. Each series still gets its own normalization, which matters because different assets can have wildly different price scales and volume behavior. The web UI is useful because visual inspection catches problems quickly. You can upload market data, choose a model, select CPU, CUDA, or Apple Silicon MPS, and tune sampling controls like temperature and top P. The chart places the forecast next to the actual path, so unstable output or messy data is easier to spot before deeper testing. Fine-tuning is not treated like an afterthought. The repo includes a QLib path and a custom CSV path, which gives you two ways to adapt the model to your own market. The training flow also keeps tokenizer work separate from predictor work. That is a serious detail. If the tokenizer defines the market vocabulary, then adapting it to the data distribution can matter before you even start tuning the forecast model. Data preparation is still the unglamorous part. Kronos expects coherent market windows with the right columns, timestamps, and ordering. Missing values, split adjustments, exchange gaps, and bad volume data can all make a forecast look more meaningful than it is. The repo gives you a better model primitive, but clean datasets are still your responsibility. The backtest example shows where the forecast fits in a larger research loop. Kronos produces a signal. The demo turns that signal into a simple top-K strategy and compares it to a benchmark. That is helpful, but it is not the same as a real trading system. Production work still needs portfolio construction, transaction costs, liquidity checks, risk limits, and assumptions about whether the signal survives outside the sample. Compared with generic time series frameworks, Kronos has a sharper point of view. It is designed around candlesticks, not arbitrary sensor data. Compared with a black box trading signal, it gives you model code, examples, fine-tuning paths, and visible forecasts. Compared with a one-off notebook, it is easier to reuse. The advantage is not that Kronos knows the future. The advantage is that it gives market researchers a specialized foundation to build on. Setup is familiar if you already work in Python. Clone the repo, install the requirements, load the model and tokenizer from Hugging Face, and run one of the prediction examples. The web UI starts from the web UI folder and runs on port 7070. The first model load can take time because weights have to download. After that, the workflow is mostly normal scripts, configs, and data files. The project has a research timeline worth separating from normal app releases. The paper went on archive in August 2025. Fine-tuning scripts followed later that month. The README says Kronos was accepted by AAI 2026. The cloned repo shows an April 13, 2026 commit, and there is no latest tagged release exposed through the GitHub releases of PI. The limitations are important. Kronos is a research framework, not financial advice. The large model is listed but not open-sourced. Backtests can look convincing while still missing execution reality. Market regimes change, data vendors disagree, and small errors in preprocessing can dominate a result. The right way to read this repo is as a modeling foundation. It gives you a serious starting point, then leaves the hard trading and validation work to you. The bottom line is that Kronos makes financial candles feel like a native AI modeling target. Its strongest idea is not a trading strategy, it is the representation layer. Learn a vocabulary for market sequences, then forecast through that vocabulary. If you build research tools around stocks, crypto, or other K-line data, this is the kind of repo worth cloning and reading carefully. For more GitHub repo deep dive videos, subscribe to Build Things with AI.